Hello, hello. Thank you guys for being here. Today's a big day. Today is a big day. Why? Why do you ask? Is a big day? Well, let's take a look at this, shall we? First of all, it's Friday. It's our last, actual. So, yesterday, I think I was saying I wasn't really sure if I'm going to be streaming on the weekends, and that's still true. I don't know what I'm going to be doing. I know that I'm going to be busy tomorrow during the day and on into the evening, and so I don't know if I'm going to actually stream. I might late at night. I don't know. I'll probably stream a video at night. I don't really know though. So don't hold me to anything. Then on Sunday, I like to not do things on Sundays in general. So, not sure. Yes. So today is the last full planned day of the stream for the week, and it is the completion of the first proper work day week for the series, if you want to call it that. But so that's part of why it's a big day. It's Friday. Secondly, so we're on iterations, loop idioms. So this is how far I got. And so we got 2 videos until we're on to new territory for me. So our third one will be new. Be very exciting. And we are going to. I talked to my dad today, and I was like, there's a lot of information with I was telling him a bit about this video and stuff, how he was doing different things with, printing different stuff. And my dad, who's a programmer, he is a database administrator. That's what he is. So technically he's not like a programmer. He hasn't programmed in a while, he said. But he was saying that he does actually do this. Figuring out, different, what am I trying to say? Different characters, find different characters in code, try and, that's the only thing that really I can think that you find differences in code in order to help, find things that he needs, get rid of stuff that he doesn't, and so on. And so this is helpful, bottom line. I'll need this. And so I'm hoping we might eventually go through this again and kind of work through this more intentionally instead of passively like it was before. But we're going to be focusing on this because this is kind of where we're comfiest right now. So, without any further ado, I want to see. Okay, so there's an exercise here. How long is the exercise?
Hello and welcome.
8 minutes. Okay. Exercise there. And then the new one, strings in Python. There's no exercise. Yes. I'm excited. We only have one exercise today, folks. All right. Without further ado, let's just hop into the video.
So now we're going to talk about loop idioms. And loop idioms are patterns that have to do with how we construct loops. We have the mechanics of fors and whiles, but ultimately we want to get something done. We want to solve a problem with a loop. And often what we have to do is, if we have a set of things, whether it's lines or strings or characters or numbers, we're looking for something like the largest or the smallest, or we want to add them up or something like that. And so we can't just say add them up. We have to say go through each one and do something to each one and somehow achieve adding them up. And the pattern that we're going to follow is we're going to have this loop that's going to do run once for each thing, right, in some chunk of data.
The trick is knowing something about the whole loop when you are stuck.
And then, but we're going to set something at the beginning, and then we're going to do something to each one. And at the end, we're going to kind of get the payoff. We're going to get the result. So if we're doing
5, 4,
sort of
3, 2, 1,
summing
blast
things,
off.
we're going to have a running total. And so this will be like t equals 0. And then this will be t equals t plus the thing value. And then, but this is not the real total. It's the running total during the loop. But at the end, it is the real total. And so we're gonna look at what you do at before the loop starts, during the loop, and then what you get after the loop and how you can use that. So we're going to use this loop. It's just going to loop through a set of 6 numbers over and over and over again, right? So we're going to do something before the loop, we're going to do something after the loop, and then we're going to run the loop some number of times. And in this case, thing is our iteration variable because I'm using unmnemonic variables now. So this is going to run 9, 41, 12, 3, 74, and 15. So it's going to run and print these things out. So it runs this loop 6 times, and away we go. Now this loop does nothing except print stuff out. Of course, I like to do that first, is always print things out to make sure that sort of my brain is functioning. So to kind of understand how these loops work, I'm going to ask you to function as a program. And I'm going to show you some numbers in succession. And I want you to mentally figure out what the largest number is, but more importantly, think about how your brain is solving this problem of what is the largest number, given that I'm only going to show them to you one at a time for a little while, and your brain has to do something. And imagine I was going to show you thousands of numbers. I'm not, but imagine I was. How would you organize yourself in a way so that for like an hour and a half, you could sit here as I showed you numbers and you keep track of the largest number that you've seen of all the numbers. Okay, so here we go. Here's your first number. Second number. Third number. Fourth number. Fifth number. Sixth and last number. What was the largest number?
74.
What was it? Well, it wasn't too hard. It was 74. But that's not the question. How did your brain arrive at 74? So here's all the numbers. If I'd shown you all the numbers and asked you what's the largest number, your eyes would have sort of gone, and then you got to 74. And you wouldn't do it in any particular order. Your eyes would just like see the 74 and it would just throw smaller numbers away, and it would move really quickly to what the answer is. Even if there was several hundred numbers on the screen, your mind would sort of move fluidly wherever it felt like moving and then arrive at it. And probably what it would do is it would do something like, kind of move like this, find this, and then sort of check to make sure that it's okay, and then say like, okay, I got 74, I'm done. That's not how computers do it. That is not how computers do it. They do not move fluidly. But they are highly dedicated. They're going to do something, 74. But how would you construct a loop to achieve this? So let's take a look. You could create a variable called largest so far. And this is the largest variable, the value that you've seen in the list so far. Now, I haven't shown you any numbers yet, so we'll just set this to -1 to get us started. So now we see 3. And we're like, oh, that's better than -1. It's our first number, so it's probably the largest we've seen so far, right? Great. 41. Oh, that's bigger than the largest we've seen so far, so we'll keep it. 12 is not bigger than 41, so we're not going to keep it. Notice this keeping thing. 9 is not bigger than 41, so there's no point to keeping it. 74 is bigger than 41, so we'll keep it. Is this the largest number? We don't know. We don't know until we're done. 15, not better than 74. So now we're all done, and hooray, 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 we have the largest number. And we had this variable that we kept the largest number that we'd seen up to this point. And then when we know that we're done at the end, then that becomes the largest. So if you look at all the numbers, keeping track of the largest so far, at the end of all the numbers, the largest so far and the largest are the same thing. And so that's how you get this idea of something you're doing during the loop is not really the answer, but by the time the loop is done, you will have the answer. And so here's a bit of code that does this. Use it with our numbers, right? So let's take a look. So I have this variable called largest so far. I set it to -1. Before the loop, remember there's a loop before and a loop after and a loop in the middle. Before it's -1. So now the num, remember underscores are okay, that's my iteration variable. If 9 is greater than largest so far, well, largest so far is -1, so that's true, so this code's going to run. So we're going to remember the new number. So this is 9, and so 9 ends up in largest so far, and then we print it out. So largest so far is 9 after we saw the number 9. Then we do it again.
Okay, need to take a moment. So largest so far equals -1. Print before -1. Before -1. For the num in this sequence. If the num is larger than largest so far, then we'll do this, which in this case it is, because 9, if the num, which is 9 in the starting off, is larger than -1, the largest so far equals the num, which in this case is 9. Then it'll come up. Wait, print largest so far. Okay, print largest so far, which is, I mean, starting off, it would be, oh yeah, 9, because it got turned into 9 right here, and then the number, which would be the number that is in the sequence at the time, which in this case is 9. So then we travel back up. 41. If the num 41 is larger than 9, then turn it into 41, excuse me. 41 is bigger than 9. So 41, print largest so far. What you got was turn it into 41. But then when we get to 12, if the num 12 is larger than the largest so far, which is 41, turn it into the number, but it's not. So we just jump to print largest so far, which is still 41, and then 12. And then we changes again once we get to 74. And then once that all is done, print after, which it prints, and then largest so far, which would be at that point 74. Cuckoo.
So now 41 comes in. And is 41 greater than 9? The answer is yes, it is. So we're going to run this code, copy 41 into largest so far, and then print it out. And largest so far is 41 after we saw the number 41. Now we're going to run the loop again with 12. Okay, and you get the idea, I hope. Is 12 greater than 41, which is the largest we've seen so far? And the answer is no, it is not. So we skip. So the largest so far stays 41, even though we saw 12. Meaning we're sort of like ratcheting up, but we never ratchet back down. So we run it again with 3 and 41, and we skip this, and then the largest so far is 41, even though we just saw 3. And now we see 74. Is 74 greater than 41? See, we never are looking at all the numbers. We're only looking at the window on the numbers of the current number that we're looking at. So is 74 greater than 41? The answer is yes. So we run this code and then we capture the 74. So we just saw 74 and it is the largest so far. And then we run it again with 15, but 74 is our largest so far, and so it skips. So 74 remains largest so far after 15, and now we're finished because we just ran the last thing. The for loop takes care of everything and jumps to this print statement and says afterwards, largest so far is 74. But at this point, it's also the largest, right? So largest so far became largest when our loop finished. So that sort of gives you this notion of how we construct, something at the beginning, some kind of thing that we're going to do over and over and over again, and then something at the end. And we put some print statements in just so we can watch it and see what's going on. So coming up next, we're going to talk about some more loop patterns, some counting, totaling, averaging, and finding the smallest number.
Okay, quick video. Below's code to find the smallest value from a list of values. One line has an error that will cause the code to not work as expected. Which line is it? We could run it. We could just recreate this and run it, and it would tell us. But let's try and work it out. Is my shirt? Do I have something on my? Oh. I had like a white. I could see this white thing in me. Let me get this done. Sorry about this. Is it like a hair? Oh, it's like schmutz. What is this schmutz? Schmutz. Okay. Okay, smallest equals none. Can I still? Okay, fine. I'm just gonna cover it up. I'm gonna cover it up and forget about it. Smallest equals none. I'm not gonna forget about it. This is gonna burn a hole in my brain. But is it gone? Might be gone. I need to focus. Dang. Smallest equals none. Print before smallest if itervar in 3 for that sequence of numbers. Wait, for itervar in I think it's 3. If smallest is none, which it is, or I'm hung up because of this if statement that's right after the for. Is that a thing? Can you do that? So the for itervar in that's fine. That's going to just run the sequence of numbers. But then if smallest is, let's keep going. If smallest is none or itervar is smaller than smallest, then change smallest to itervar. Break. Oh, it's break. It has to be break. Because it's never going to run the whole sequence. Because if smallest is none, which it is, then it would change the smallest to itervar. Wait. If smallest is none or itervar. So would change, yes, break. Because break would break the sequence. It wouldn't run through. It would just say, it would say before none, and then that's it. 6. Watch me be wrong. Okay. We got it. I was a little worried there. Here we go. Iterations, more patterns. And we're going to open this up. Okay, that won't run. After this one, we're caught up to where I was before.
So now we're going to look.
Ooh, 18 minutes? Long video.
Hello and welcome.
Okay, well, let's get comfy. I'm probably going to get a drink of water. Let's do this.
Look at some more patterns of the different things we can do at the top of the loop, in the middle of the loop, and at the bottom of the loop. And the first one we're going to do is counting. Now we're going to take a look at the number of something, the number of things in our list. Now we could just inspect it and see 6, but you will have for loops like you're reading through a file or scanning through some data. And so the notion of counting, you have to assume that you don't really know, that there's going to be a lot more than just 6. But for now, we're just going to do 6, and we're going to count how many things that we see in this loop. And the pattern is simple. You set a variable, Zork, to 0 at the beginning. We often call this variable count in mnemonic. And now we're going to run this loop 6 times, 1, 2, 3, 4, 5, 6. And each time through, we're just going to add 1 to Zork. So Zork starts at 0, then it goes 1, 2, 3, 4, 5, 6. And we're going to print it out. So, we see the 9, and Zork is 1. See 41, Zork is 2. And Zork is 16. When we see the 15, 4 stops, and we print out afterwards. And this then is 6 is then the ultimate count that we got. So that's very, very simple. The pattern is that set it to 0 at the beginning, add 1 to it, and if you run that enough times, then this is how many times that happened. And in a sense, it's how many times this line ran, right? Sometimes you put this in an if statement, et cetera, et cetera, et cetera. Okay? Oops. Now, we can do the same thing to get a total. The way the total works is you compute a running total of the number of the items that you've seen so far, and at the end, the running total, in effect, becomes the total. A better variable name for this would be like sum or total or something, but Zork, I'll use Zork again. So you set Zork to 0, and it starts out, the total we've seen so far is indeed 0. And then we're going to run this 1, 2, 3, 4, 5, 6 times, and thing is going to be the iteration variable. It's going to take on the successive values. And each time through, we're just going to take our running total and add to it the thing we've seen. So we see 9, and the running total is 9. We see 41, and the running total becomes 50. We see 12, the running total becomes 62. We get a 3, it becomes 65. We get 74, running total is 139. How many more are we going to see? We don't know. Could be a million. Could be 1. Oh, it's only 1. We get a 15. Our running total is 154. And what's true at any moment here is the running total is right up of what we've seen so far. Now, when we're done, the for loop quits for us, and afterwards, 154 is indeed the total. So the running total while we're in the loop, at the end of the loop, after the end of the loop, we have the actual total. So it's not very difficult to convert this to the average, because we've calculated the count and we've calculated the running total, and now we're going to have the average by simply dividing those. Okay, so now this time I've used mnemonic variables. Don't get confused by this. Mnemonic variables are just friendly names I chose for you to read the code easier. I am not communicating to Python in any way by naming this count and sum, but count and sum is nice. Okay, so I set count to 0 and sum to 0. Oh, go back up. I set count to 0 and sum to 0 at the beginning, and the count is 0 and the sum is 0. And then I'm going to run this loop 6 times, 1, 2, 3, 4, 5, 6, and each time value is the iteration variable. I count, every time I run the loop, I count equals count plus 1, sum equals sum plus value, so I have a running count and a running total, and they show up here, 1, 2, 3, 4, 5, 6, and then the running total. And then at some point, the for loop, we do the last one, and the for loop jumps out, and it divides 6, 154 is the count and running total, and then it divides the average sum over count. Okay? So that's just, again, a pattern of something in the beginning, something in the middle, something in the end. Another kind of thing we tend to do in loops is we look for things, we hunt for things. And so this is where we have an if statement inside of a loop, and of course I've created a silly simple thing. In this code I am looking for large values that are greater than 20. And again, don't think of this as just 6 numbers, but I'm looking for all the values and I'm going to print them out. So, it says before, it's going to run this 9. Well, if 9 is greater than 20, it's false, so it goes back up. 41, true, so it prints out 41, then goes back up. 12, false, goes back up. 3, false, goes back up. 74, true, so it runs this, so out comes that little print statement. Goes back up, and then 15 is the last one, and that's false. It goes back up, and the 4 says, we're done, and then we do afterwards. And so this is just the notion of having an if statement inside of a for loop, where we're sort of picking or choosing or selecting or looking for something in a large set of things that we're looping through. We can also say, I want to know if a particular value is there. And so we're going to use a Boolean variable. And we've talked about integer variables like 1, 42, and then floating point variables like 98.6, and then string variables like hello world that have quotes in them. This is a for.
If value is 3, found equals true. So print found, which would be true, value, which would be 3. 74 does not equal 3, so therefore okay, so it'd be true, true, true after it found 3. It doesn't revert back to false. Once it's 3, found equals true, and it does not go back. So it's like false, 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 true, then true, even though 74 does not equal 3. It's basically a switch. Like it flips a switch. Once it's 3, flip the switch. I don't know.
Type, a kind of variable. It's called a Boolean variable, and it only has 2 values. It has true and false. Matter of fact, these if statements, they return Boolean values. Value equal 3, that is returning a true or a false based on the value of value. There's a mnemonic confusion there, right? But I'm using it. So I'm going to make a variable called found, and that's a decent name for a variable, so don't get hung up on that. And I'm going to initially say found is going to indicate to me whether or not I found a 3 in my list. And I'm going to start before the loop starts, say false, because we haven't found anything yet. So found equals false. And so at the beginning of the loop, found is false. Before the loop starts, found is false. And now we're going to run this loop a bunch of times. 9, is that true? No, skip. 41, is that true? Skip. 12, skip. Right? So 9, 41, 12. And found has remained false because we haven't done anything to it. But now in comes a 3. And this becomes true. So it runs this code. So found becomes true. And then we print it. And you'll notice that when we see a 3, we get true. And then it runs again. We get 74. It's still false. 15. It's still false. Run, 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 quit. And the residual afterwards is true. And in fact, if you didn't know any of this and you don't print that out, all you know is that afterwards we loop through all those things and we know that there was a 3 in there.
Oh.
That's what we're doing. So we searched all of them. We checked for 3s when we found a 3. And you can see basically that, you know, the found remains false until it flips to true, but then there's nothing to set it back to false. There's nothing in this loop that's going to set it back to false. So once it sort of catches the 3, then it remains true for the rest of the loop, and then it just finds its way out. Now, if you want to think about it for a moment, ask yourself, how might we make this loop more efficient by putting a statement right in here? Think about a way to, once you found it and it's true, there is sort of no reason to keep on going. So
right.
What would you put there to perhaps make this loop to look for 3s, just to tell you whether or not there was at least one 3 in there, how to make that more efficient? Just think about that.
Break.
Okay, so now let's look back at the largest value that we started out with, right? And so if you think about this, let's kind of give it a sort of a rough look here. Largest so far is our kind of like a running total, but it's our hypothesis is the best large number. And we have this if statement that says if the number we just see right now is greater than the largest so far, then capture it, right? Take whatever number we saw and capture it. So when we see 9, it's better, we capture it. We see a 41, it's better, we capture it. We don't capture this, we don't capture this, we capture the 74, and we don't capture the 15, and that's how we do it. So you could think of this as better. When the number we're looking at is greater than our working hypothesis of the largest, we grab it because it's better. So this line right here is the grab line. Grab it. Okay? So then the question is, how would you modify this code to teach it to find the smallest value in this list of numbers?
Just switch it.
Think of it as you have a starting number, you have a sort of what's better in this grabbing notion. How could you do that?
Take a look. Smallest so far.
Okay, so let's take a look. So let's do a couple things. Like if you look at this if statement, that's better. Well, it's better now if the number is less than. So but then we should probably change this to be smallest so far, 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 right? Matter of fact, that's what this is. We've changed the word largest so far to smallest so far, and we've changed the greater than to a less than. Is that going to fix it? I'll give you a second to look at it. Pause if you need. Is that going to fix it? Is that going to find our smallest number?
Need to be a big number.
The answer is, of course, no, it's not. So if we run this code, so we set the smallest so far to -1, and it starts out -1. We run it, and it's 9. Is 9 less than -1? No, it's not. So after we see a 9, the smallest so far is -1. Now we're going to run 41. Is 41 less than -1? No, it is not. So the smallest so far is still -1. As a matter of fact, it isn't the smallest so far anymore. Just because we named it smallest so far doesn't mean it is the smallest so far. It didn't work out so well. And so you see that none of these, because
wait, what do you say? It's not the smallest so far?
So far anymore. Just because we run 41. Is 41 less than -1? No, it is not. So the smallest so far is still -1. As a matter of fact, it isn't the smallest so far anymore. Just because we named it smallest so far doesn't mean it is the smallest so far. It didn't.
Wait, what? Why? Yeah, it is. Right? Smallest so far is -1. So yeah, it's not the smallest number in the sequence. Strictly the stuff in the brackets, but I think that's what he was saying.
Work out so well. And so you see that none of these, because they're never less than -1, do anything. And we claim that afterwards the smallest we've seen so far is -1. And that is because, of course, -1 is smaller than any of the numbers that we saw.
Cracking my elbow.
So how could we fix this?
Or forearm.
Well, if we started the smallest so far with some like arbitrary big number, then it'd be better. So if we made this 100, whoops, come back. If we made this be like 100, that'd be good, because the first time through, the 9 would be less than 100, so we would capture the 9, and then the rest of the loop would work just fine. But then what if we didn't know how big these numbers were? As a matter of fact, the largest so far wouldn't have worked if all the numbers were negative. Think about that. We just assumed they were positive, and so we kind of wrote lazy code that assumed all numbers were positive. That might not be a good assumption depending on the numbers that you're dealing with, right?
Okay, this part hung me up the first time I listened to it when he was like, if all the things were negative.
If we made this 100, whoops, come back. If we made this be like 100, that'd be good, because the first time through, the 9 would be less than 100, so we would capture the 9, and then the rest of the loop would work just fine. But then what if we didn't know how big these numbers were? As a matter of fact, the largest so far wouldn't have worked if all the numbers were negative. Think about that.
I still don't really get what he was saying, but like, it wouldn't have worked. Are we talking like -1 is greater than? Excuse me. Like the, what do you say?
The numbers were negative, how big these numbers were. As a matter of fact, the largest so far wouldn't have.
The largest. So is he implying that like -74 is greater than -15?
Worked if all the numbers were negative. Think about that.
I don't know.
We just assumed they were positive, and so we kind of wrote lazy code that assumed all numbers were positive. That might not be a good assumption depending on the numbers that you're dealing with, right? So maybe 100's a good number to start with, or maybe like 1,000 or 10,000, or like some number with lots of zeros in it. How big should we make this? And the answer is we're kind of solving this problem the wrong way. And the thing we really want to do to solve the problem is to just accept the fact that if we're looking for the smallest number so far, that the right hypothesis is the first number. And if we just knew what that first number was, the 9, that would because it's the first number, we know that it's both the largest so far and the smallest so far as soon as you see the first number. But we don't know here before the loop starts what that first number is. I mean, you can look at it, but assume this is just data that's coming from somewhere else, and we don't know it until we start reading it. So we have to construct a loop that deals with the fact that we want to capture the first value as our hypothesis for smallest so far. So how do we do that? Let's take a look.
I don't remember this.
So what we do is we use yet another type. So we have integer, floating point, string, Boolean, and now we have a thing called the none type. None type is a special marker in that it only has one value. Boolean has true and false. You know, floating point has an infinite number of values, and integer has an infinite number of values, but none type has one value, none. None is a constant. Capital none is a constant. The difference is we can check to see if we have stored none. None is often used to indicate emptiness, not non-existence, because smallest doesn't exist until we assign it, but we're going to assign it to like a mark, a flag, a marker, some way to say, oh, this is not even a number, it's nothing. And so we're going to, and you can do this. So that's like makes a variable called smallest, and in it puts none. It sticks it right in. It's not a string none, it's like a special type. Okay? So that actually captures the notion that before the loop starts, the smallest number that we've seen so far is none. We haven't seen any numbers. Okay? So then we come in and we have an if statement.
Cool.
And we have a new operator called is. Is stronger than equal sign. And so if smallest is none, that becomes true. It runs this case. And so then what it does is it copies this first value, which is 9, into smallest. And so we see a 9, and the smallest so far is 9, which is the first value. And again, we're assuming we don't know what the first value is before the loop starts, so we use the first iteration through the loop as the moment where we capture that. Okay? So smallest is the value, and then we print it, and we go back up. And now it runs again with 41. 41 is not none. None is, there's only one thing that's none. So it is not equal to none. Smallest is not equal to none, or is not none. So this is false, so it skips over here. Then it asks the question, is the value we're looking at, 41, less than smallest? Well, smallest is 9 in this case, and this is 41, so that's false, so it skips that and goes on. So we see 41, we don't take it, and then you can see that this will never become true again. This is pretty much false for the rest of the iterations of the loop. That's false for the rest of the iterations for the loop. So it just is going to run down here and ask this question. And at some point we see a 3, and we run this code, we capture it. We see 74, we don't capture it. We see 15, we don't capture it. So then the for loop skips out, and at the end we have the smallest. And actually this would be a good technique for the largest as well, because it really is just a technique to put a marker in this variable so that we snag that first number or first whatever as we read and parse through them. So the is and is not operators are very useful in Python. You can think of them as like the double equal sign. They're asking a question, and they return a true or, blank is blank, returns a true or a false. It is stronger. Double equal says, are these things equal in type and value? So just as an example, if I were to say, is 0 equal to 0.0, it would say, yeah, that's true. But then if I says 0 is 0.0, that would be false. So that's because these two are the same value-wise, and these two are not the same type-wise. So is stronger than equals, meaning that it demands equality in both the type of the variable and the value of the variable, and no conversion is done. And so that's just a very strong. Don't overuse is. If you're dealing with numbers or even strings, use double equals, don't use is, because sometimes it gets a little confusing. So use is sparingly. I tend to only use is on Booleans and on none types. I don't use is on integers, and I don't use is on floats, and I don't use is on strings. Just none or true false. And also, is not is also an operator. So you just say blah, blah, blah is not none, or blah, blah, blah is not false. Okay, so we've been looping around and doing loops and loops of loops. We looked at the indefinite loops, the while loops that kind of run for a while. The definite loop, and we looked at break and continue as a way to either escape completely from the loop or go back up and discard the current iteration of the loop. We looked at none. We looked at Boolean variables with for loops, definite loops, where you've got some kind of a set or a list or some kind of sequence that you're looping through. And then the concept of loop idioms, where you do something at the top, something to each item, and then you sort of get a benefit at the bottom. And so that gets us through iterations.
Cool. All right, we'll do the exercise, but first, which of these evaluates to false? That would be this one. 0 is 0.0 because it is not 0.0. Yeah. Strings in Python. New ground for me. But before we do this, boom. What are we doing?
Welcome to Python for everybody. I'm doing a worked example. My name is Charles Severance, and I'm the instructor for the class. And the worked example that we're going to work on right now is in Chapter 5, and it is Exercise 1. We're going to repeat asking for a number until the word done is entered, and then we're going to print the total, and then we're going to print the count, and then we're going to print the average at the end, and we're going to enter some numbers, and then we've got to do some error checking. And we're going to keep on going, so we'll ignore this. We'll just say invalid input, and then we're going to ignore it.
Okay. Let's do this then. We'll just start working stuff out here, and if we get stuck, we'll watch the video. Okay. So we'll do this. Gobbledygook just to save as exercise 7. Write a program which repeatedly reads numbers until the user enters done. Total count and average. Okay. Okay. So let's sum equals none. Count equals none. Number. Now this is now where we're going to get into input. Number equals input. Please enter a number. Now let's just try this out, just right off the rip. Actually, not right off the rip. Because we need to loop back. And that's the hard thing. It'd be if number equals done break. And it also needs to be number equals input. Number we'll put input num equals input, please enter number, and then output num equals input number int input number, so that turns it into an integer if output number equals done. Well, that needs to be in front. Right? What does this even do? Please enter a number. Really? Oh. If line oh, it's I. There we go. Okay. I like how it like helps us out, you know what I mean? Can you see that? Oh, you can't see that. I'm sorry. Down here, you see this? How it says, maybe try this. Break outside of loop. Oh, man. There's different like things we need to tackle here, and it's kind of tricky to. Quit? Whoa. Whoa. I don't know what that is. Okay, whatever. Just add that. Done. Would it be count? If count. Getting a bit stuck here. Let's watch a bit.
So I'm going to start from scratch. I'm going to write a, I'll start my terminal, start some Atom. And so I've opened the PY4E folder, and that's kind of cool because now I can do things like say new folder and say I'd like an exercise 0501, and then go into exercise 0501 and say file, new file, and then say file, save as, and put it in exercise 0501, and then name the file ex0501.py. I'm going to start from scratch on this one instead of adapting another piece of code. I'll say print 5. And I'm going to do this because now I need to get to the point where I'm in the same folder in this terminal window. CD desktop, Py4E, EX. I can string these together. And there I am, and I say Python 3, EX, and there I go. Okay, so I'm in good shape.
So I saw this and it's like, I was trying to write it in parts, which is kind of what I was thinking. But it works better if you think about it as a whole. So let's kind of, I want to try this again. Let's kind of scratch this. Let's do a count. For num in, whoops, we'll do if we're getting somewhere, ifs make this none. Oops. What the heck? There we go. If sum is none. Sum equals num. Else. Sum it has to be 0. Because it can't be none. Because we can't add a 1 to none. Wait, we can. We'll try it. Else sum plus 1. Elif. There should be an elif. Sum plus 1. Then, so that's the count, right? It's going to keep on sum equals none for number in 2, 4, 6, 8, 10. If sum is none, sum equals number, just 2. That's going to take 2 plus 1. Wait. That's going to be like 3. That's not what we want. I mean, that would be the sum, though. Sum plus num, because... Oh, frick. So... Oh, no, that's okay. So num equals none, right? That's the first thing. If sum is none, which it would be, it would turn into 2. Then it would take 2 plus the number, which is 2. Right. Then head back up. If sum is none, which it isn't, it would skip over that. Elif, it would take sum, which would be 4. Elif. Oh my gosh, man. We need something to print, because otherwise we're not going to see anything. Print. Could do an else. Else. Print. Some. What does this even do? Line 5. Elif. Why is it? Isn't that what you do? Elif? Colon? Else? Do I need an else? After Elif? I just kind of want to come up with something. You know what I'm saying? What the deuce? 222. Why did it print 4 things? Oh, because there was none originally. Wait, what? Oh, gosh. Kind of looking down here. Oh, y'all can't really see that, sorry. Sum equals none. If sum equals... I mean, I feel like none isn't the way we should go here. Everybody else is doing 0. What? Sum equals 0. If sum equals 0. Sum equals none. Really? That ran cleanly, I think. So let's just do count equals 0. Oh, let's try something here. If sum equals 0, count plus 1. And then sum equals num. Print sum count. Right? So why didn't that work? For sum, if sum equals 0, count plus 1. I don't understand.
So there's a couple things right now, and we're
watching.
going to do the total, count, and average. And so this is just a basic pattern where we're going to have, we're going to need a iteration variable for the count. I'll call that num. We start that at 0. And then tot, and I'll start that at 0.0. So that's the running count and the running total. Now we need to write a loop. And I'm going to write this as an infinite loop.
While? Let's kind of follow along, folks. I might need to back down the number of videos that I do a day. Right now we're doing 3, you know? But it's like in order to focus on doing stuff like this, I might need to back it down and not just have it take up all the time in the word, because this stuff is important.
While true with colon, and then I'll indent.
While true.
And I'll prompt for a string. And remember, input gives us a string, so I'm going to call this sval equals input enter a number, colon, space.
While true. As full. I still don't really get. Let's try something. If as vol whoa. I don't know what that was. Print done with sequence. What? Oh. What? Break. I'm trying to think of something to break out of the loop. Quit? Wait. Done is not defined.
I'm going to deal with the try and accept later, but you
Okay.
can just kind of know that the floating point value that we're going to do is sometimes this little bit of code
Float as vol.
will fail. I'm just going to take the string value here, sval.
Okay, I understand. Wow, true. So that's where he turns it into a float. I should do that more often instead of integers.
This input returns us a string, and now I'm going to convert that to a float. I'm going to say print fval. So
Print. Let's just do this here. Just to feel like we're doing something right. Uh-oh, now we're kind of stuck though. Okay, that works.
So I can print
I'm
that
just,
out.
I can't think of what
and then I'm going to do
with this.
the num equals num plus 1.
Okay. Num equals num plus 1. Then at the end of all this, we're going to print num at least. So like 3. Whoa. Oh no, that's fine. 6, 4. Quit. Bro, this is stumping me.
And tote equals tote plus fval.
I'm sorry, I'm for just watching the video so much. This one is tough. Tote equals num plus fval. Oh, num. Okay, so num equals num plus 1. Okay. Yep. Like the total. I feel like that's not right. How can that be right? Why would you add the number to the FL?
Now,
Wait, did I just do it wrong? Oh, shoot, I did it wrong. Whoops.
I do need to deal with the situation where I'm entering the word done.
Yeah.
Now, we want to check that before we convert it to a float, because done, well, we can run this. It's an infinite loop, but it'll only run a little bit. It won't cause us too much problem. If I run Python, let me drag this over here, and I go 1, 2, 3, and if I put in something bad, it's running. I don't have a way to get out. But you can see that, it blew up on line 5. It blew up right here.
So I saw what that dude did down in the comments. So if svol done break. Then what? Is that what homie did down here? Really? Oh, it did make a difference. Oh my gosh. Okay, hold on. So let's try something here. We'll do 1, 2, 3, 4, 5. 5 times. Because it added it. Okay. It added it. 1, 2, 3, 4, 5. Sorry, I've still got this up here. I'll scroll up so I'm not cheating. I already did cheat. What am I saying? But anyway, let's try and get some of this ourselves now. Break. Elif. Asphalt equals type string print, please enter a number, or we'll just say error, right? Error. What? Elif. Oh. Now 10. Is that kind of the point? Print error? He's giving me a trace back. And then continue. Again? I'm trying here, man. All right, let's kind of set this to the side for a moment. We'll get rid of this. We'll leave the error code in. We'll just kind of comment it out for now so it doesn't cause problems. So for total, we got total. Plus S or plus F file. So if we put in like 5, be like 0 plus 5, which is 5. Tote. So then if we go down here, we'll go like 2, 4, 6, 8. Done. Awesome. And then we'll do can we do this? Tote divided by num for the average. Do this again. 2, 6, 8. Done. Okay. So that worked. Man, these errors, though. How are we supposed to put in these errors? If festival is done, break. Let's take another peek. Accept. Wait, that was he used a try and accept. We're not using a try and accept. Wait, so she used to try and accept too. I don't know why she's per gun to done. And then she did try. Let's try this then. Okay, we'll scroll up so we're not just like looking at all the code there. Hide. So this should work. While true, enter number, break, try. So this is like a while true thing. Try FL, turning it into an print, accept. What? Why is it doing this to me? Accept, print, error. Line 7. Oh, maybe. One. Wait, is prints it all right there? It works. Oh, so it just prints. So let's comment that out, shall we? Oh my gosh. Oh my word. It worked. I'm calculating on my end the The average. I had to cheat, but we eventually got it. Divided by 4. Yeah, it's right. What's with the stream bot, yo? Y'all see that? Stream elements bot? We get it. You're running. All right. We did it after cheating a bit.
Here in line 5. So what we want to do is we want it to say, you know, 1, 2, 3, done.
Let's compare
But
our
we want it
code
to
his.
detect that we've typed in done. So here we'll just say if the string value that I got back from input is double equal, quote, done, quote,
Yep. The quote
break.
got me. Okay.
So that basically will break us out. And now print all done. I should be using single quotes here. Too much Java coding. Print all done. Then I'm going to say print. What do I want to print? The total, the num, and then tote, comma num, comma tote over num.
His variable
Now
naming.
We've got to be careful because we don't want to divide by 0, but
Trips
that'll
me.
get us sort of a ways. So this is going to run, it's going to read these things, it's going to accumulate here. This is the accumulator pattern. This is a counter pattern where we're adding 1 to a current variable, and accumulator pattern where we're adding a value to it.
Okay.
So now we should be able to see the done. 4, 5, and 6, and then done. And the total of 4 plus 5 plus 6 is 15. The number is 3 and the average is 5. And so that's really good. The all done prints out. I just did that for yucks, and you can see the value that's coming out. So that's in pretty good shape. So I'm going to comment this out and comment that out. So this is pretty good. It works just the way we want it to work. 4, 5, 6. But if we do something other than we're done, then we're going to blow up in this float. And so this is where we're going to have to do a try and except, because we just know that this line, line 7 is the danger zone. Okay, so what we're going to do is we're going to put a try in here, and then we're going to indent the part of code that seems strange, and then we're going to have some except code. And the first thing we have to do in the except code is print out the word invalid input.
Oh, whoops.
Come back.
I mean, it doesn't really make that big of a difference.
Print invalid input. Now, just like in an earlier example, we have to do something here to make sure it doesn't just keep on going, because fval doesn't work. We're not going to see the error message that would be the traceback here on line 9. We're going to run here, but we still don't want to add, because fval will be... so this is where we can use the continue. So in this code, we're using both the break.
Oh, interesting. This is where we did stuff different. So
To say if I'm all done break,
hold on.
and if I have a problem, I'll print a message out, and then I'll say continue. So the
Interesting. So he put the except before this and had to do continue. So really, we just saved a line of code, i.e. continue.
continue basically says go back up to the top. So that is how, when we see enter some bad data, we print an invalid input, and without adding anything new, you don't really see it here, without adding anything new, you go back up to the top and enter a second thing. So now, if everything is right, I should be able to type bad input. 4, 5, 6. Bad input, done. And I have a total of 15, add 3 items, and the average is 5.0. So there we go. That's what we're going to get, and that roughly achieves the same thing. And it's a combination of a loop with a exit mechanism. We have some sanity checking of our input, some making sure that we have some valid input, and we catch it, and we use continue to loop back up to run the next iteration of the loop. And we have an accumulator pattern, and then we can use the accumulated data to print what we want to print. So I hope that this has been useful to you. Exercise 5.1 for Python for everybody.
Excellent. So what did everybody else do? Try. I don't like her. What is her supposed to? Pergunta? I don't get it. I mean, to each their own. You can name your variables what you want. It's confusing to me. Here we go. Wild true. So what's going to hang me up, right, is understanding the differences between like whiles and tries. Try and accepts, if else, whiles, fors, while true, if number is done, break, try, num, print, okay, I'm glad we're not the only ones. Do you see this? I worked for hours on this exercise, trying it on my own to no avail. Okay, what did this person do? Oh, he had an average total count average equals 0. When average always be like, wow, I don't think you needed average. He didn't need average in there. While true, try, input. See, I like this. That sort of, let's see, if input is done, break. Turns it into an integer. My guy. See, that's what. Accept value error. See, what's this? Why do you have to do this? Print invalid input. Continue. Total. Plus or equals input count plus 1. Okay, so that's the count. Add set up average equals. Oh, totally. Okay. So we just did that a different way. Average equals total. Or count divided by total. Print total count average. See, I just don't know that I would have been able to do it by myself without, like, looking through some stuff. Know what I mean? Know what I mean? Because it's like I was just on the wrong path without the try and accept. Is there any way to do this without the try and accept? I don't want to try. I'm scared. I'm scared I'm going to make myself more confused. Not more confused, but make myself confused. Because I have a decent handle on this, but... I think the next time we do this, we might try and write this from scratch. Oh, that's cool. It puts a little red dot by the line you're on, or you're currently highlighting. But it's like I want to get this, you know what I'm saying? I want to get it. But with that, I think let's move on. Looping through strings. Is this long? Okay, not super long. New stuff here now. This is new for me, so I want to be taking my time on the slides, trying to understand. And after this, I feel bad, man. I feel bad that we couldn't do this. Here, I want to try without looking. Right. Get it out of my head, my memory. We'll go. Count equals 0. I'm all nervous, man. I'm all nervous. I'm gonna do. Okay, so while true. Does this need to be capital? Yes, it does need to be. Oh my goodness. True. While true. Input equals input. Please enter a number. Try. Equals. Oh, float imp equals float INP. Try turning INP into a float. Num I'll make this total up here. Count plus 1 print hello print count tote divided by count. Whoopsies. Whoa. Why aren't these blue? Shouldn't they be blue? It doesn't need to be. No, that's not right. That can't be right. We'll worry about that later. While true input please enter a number. While true input equals let's tote equals tote plus FINP. Except print. We're doing it. I think we're doing it. Invalid. We'll just leave it like that. Not too harsh. Okay. We need an escape clause. If INP done break. This is a mess up thing right here. I know it. Wait, what? Oh, gosh. Wait. Oh, no. So aggressive. Invalid. Wait. What is this? 0 division by 0. Trace back. 17. Oh. Oh, it'd be total. Oops. Right? Oh, crap. I'm sorry. Toad. Zero. It's done break. So done's working. Done works. Try turning it into a float. Count +1. Why isn't it counting? Why isn't it counting? Try. So total works too. Total works. Let's try doing what the other dude did. So we just do average equals tote count tote average. Try that's it. Let's try it. That has to work for count. That has to work for count. This has to work for count. Wait, did I just do it for freaking... That can't be right. Let's flip this. Flip. Because I don't think that's right. 2. Whoopsies. Sorry. I did it. Let me check. 2 + 4 + 6 + 8 divided by 4. Oh, that works. And 4. We did it. I'm gonna save it. We did it. I hope I saved the other one. Not that it really matters all that much. Oh, wait. Let's try this then. Whoops. Shoot. Okay. Oh, it works. It all works. Done. Okay. Oh. Oh, we did it. That feels good. That feels good. Sorry if that was a drag for everybody, but that feels good. That was helpful. This stuff right here is what it's all about. This is learning, man. This is going to be the job. This is going to be the job, doing this sort of stuff, troubleshooting, working through. That feels good. That feels good. All right. Now, with a clean conscience, let's move on.
Hello and welcome to Chapter 6. In this chapter we're going to talk about strings. And Chapter 7 is the payoff chapter. So we, up to this point we're still learning sort of basic building blocks, and actually we're going to write a real program in Chapter 7. So just learn this, and the payoff's in Chapter 7. So we actually been using strings.
Okay. Oh my.
Actually been using.
Hold on. Okay. Hold please. Can you see me, or can you see the? Let me drag myself out of the way. We'll live over here for a little bit. All right. String data type.
Strings from.
A string is a sequence of characters. A string literal uses quotes. A string literal. For strings, plus means concatenate. When a string contains numbers, it is still a string. We can convert numbers in a string into a number using int. String 1, hello. String 2, there. Bob equals string 1 plus string 2. Print Bob, hello there, all together. String 3 equals 1, 2, 3. String 3 equals what? String 3 plus 1. Oh, because we need to turn it into an int. Excuse me. X equals turning string into an int plus 1. Print x 1, 2, 4.
In the very first lecture, because if you print hello world, well, that's a string. And so we've been doing things. This slide here is all review. We use plus to concatenate strings. We use print to print them out. Print's just a function that takes as a parameter something, strings, integers, etc. We can put digits in strings, but we can't add to them. By now you've figured this out, but you can use things like ints to convert the strings to integers and then print things out. So, we've been doing this for a while. We've been talking about strings all along. Now today, what we're going to do is going to just get into strings in more detail. We input data with the input function. Input returns us a string. And if we want to input a number, we have to run some kind of conversion, like we have to do on int before we take this data that we read from input, and so there's things that we've got to do, and we've been doing all these things. And we take this data that we read from a number, we have to run, and if we want to input a number, we have to run some kind of conversion, like we have to do on int before we take this data that we read from input, and so there's things that we've got to do, and we've been doing all these things in programs so far. But if we look in a little more detail inside.
So this is interesting. The video that we saw from Corey, is basically what we're doing over here now. So I'm kind of wondering if we should just stick with this and supplement videos from Corey as needed. That might be what we do. We can get at any single character in a string using an index specified in square brackets. Oh. The index value must be an integer. What? It starts at 0? Okay. Oh, like the string always starts at 0, like the first character in the index starts as 0. The index value can be an expression that is computed. Oh gosh, that's horrible. Fruit equals banana. Letter equals fruit 1, which would be A. Yep. X equals 3. Which is irrelevant. Wait, no, never mind. I'm sorry. So W equals... This is so crazy. So W equals fruit. But then in the index, it's X minus 1, which is then 3 minus 1, which is 2, which makes it this N. Print W, which is this, and that's an N. Oh my goodness. Oh, that's bonkers, man.
Strings. We can index within strings each character. So each character has a separate position and a separate index. And they basically, the letters have positions, and the positions start at 0. And the best way I explain this to remember this is it's the elevators, as we used in one of our examples a long time ago. Elevators in Europe start at 0, and so strings start at 0 as well. Turns out in the old days there's some efficiency with the notion of lists of things starting with 0. These days the efficiency isn't the issue, but there's a certain elegance starting at 0, even though intellectually you might think 1 would be the first character in the string. Might make most sense to be sub 1, but it's not. It's sub 0. But just remember that. And so we have this operator called the index operator, and it's square brackets. So, fruit is a variable that contains the string banana, and then fruit sub 1 is the character that's in position 1. Now that actually is the second character.
How do you say
I'll
it?
keep reminding you, the string banana. And then fruit sub 1 is the character that's in position 1. Now that actually is the second character. I'll keep reminding you until I get tired of reminding you. And so that assigns A, the letter A, into, the letter A into the variable letter. Of course, that's a badly chosen. It's either a well-chosen variable name or a badly chosen variable name. And the thing that goes inside this can either be a constant or it can be an expression. So this is X equals 3, and then fruit sub X minus 1, well, that means 2, which is position 2, which is an N, and so that gives us an N. So the index is an operator, and you can add this bracket syntax to the end of a string variable. You can't index.
What do we got here? You will need a Python. I'm sorry. You will get a. I'm sorry, it's a little late. If you haven't noticed, it's a cheeky. Oh, you can't see it, but it's late. Late at night. You'll get a Python error if you attempt to index beyond the end of a string. So be careful when you're constructing index values and slices. I'm sure you'll tell us what slices are. The homie Corey kind of told us a little bit about slicing. Zalt equals ABC. Print Zot sub 5. So it'd be 1, 2, 3. There's not a fifth slot, obviously. Most recent call. Last file. I don't know what that is. Line 1. In module. index error. There we go. String index out of range.
Index beyond the length of the string. So if I say zot sub 5, well, there's only 3 characters, which means 0, 1, 2, but sub 5 doesn't work. And of course, we get a happy little trace back.
Did I say 1, 2, 3? Whoops, I think I did for the amount of characters. Whoops.
So you have to be careful when you're starting to pull stuff out of strings. So some of the things allow it, some of them don't, and then you'll kind of get used to that. We can ask how long a string is.
Strings of length. The built-in function len gives us the length of a string. This is exactly what Corey told us the other day, I think. Fruit equals banana, print, length, fruit, 6. No, that's confusing. It says 6, but it's 0, 1, 2, 3, 4, 5. Well, you got, though, this is a character, so it's like 1, 2. Or this is like a value. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay.
And so we use the len function. We pass the string variable, and we pass it into len as parameter, and len gives us back the length of the string, not the position. So it's 0 through len minus 1. So it's 0 through length minus 1.
Wait, what?
The length of the string, not the position. So it's 0 through len minus 1.
What? Why is it that?
So it's 0 through length minus 1.
Why would you?
String, not the position, parameter, and len gives us back the length of the string, not the position. So it's 0 through len minus 1.
That is so confusing, bro. Why would it be said like that? Zero.
So it's 0 through length minus 1.
That is the most confusing.
Into len as parameter, and len gives us back the length of the string, not the position. So it's 0 through len minus 1. So it's 0 through length minus 1.
I'm gonna move on from that. So.
So length is just another function that we've been doing functions now for a while. You pass in a parameter.
Okay, here we go. Fruit equals banana, x equals length of fruit, print x. So we got 1, 2, 3, 4, 5, 6, 6. Banana, a string. It's thrown through length, which is the function. Spits out 6, which is a number. A function is some stored code that we use. Yep. A function takes some input, produces an output.
And then len does some work, and out comes 6, and that goes back into x, because the function has a residual value. It just happens to be a built-in function. And so, you know, somewhere deep inside Python, there is code that takes this, and somebody wrote a loop or looked something up and then returned a return value and sent back a 6 to go into our x variable. And so a function is there, and like I said, we've been using this for a while.
Here we go. Looping through strings. Using a while statement and an iteration variable and a len function, we can construct a loop to look at each of the letters in a string individually. Fruit equals banana. Index equals 0. While index is less Oh, no. This is going to get complicated. Oh. Okay. Oh, let me yawn. While index is less than the length of fruit. 1, 2, 3, 4, 5, 6. Letter equals fruit. Index. Print index. Letter. Well, a letter is not. Oh, letter's defined right there, duh. Index equals index plus 1. But that comes after the print, bro. Oh, wait, no, it starts at 0, duh. Okay, so print. No, I'm sorry, let's back up. Fruit equals banana. Index equals 0. While index is less than the length of fruit. Letter equals oh man, it is too late for this. Letter equals fruit index. So right now print 0 letter. Letter equals fruit. Fruit equals banana. Index equals 0 at first. Oh, I think it's making sense finally. Oh my gosh, I get it, everybody. I understand. Okay, so. Oh my word. I would never be able to write this on my own, but I understand it. I want to say never, but right now. Oh my word. Okay, so. Fruit equals banana. Index equals 0. While. This is like the motor, right? This is like the big part of the motor. While index is less than the length of fruit, which is 6. Letter equals fruit 0. Because index equals 0, 0. So letter equals 0. The 0, the character that's in the 0 position in fruit, which in this case is banana, to B. Print index, which is 0 still, and then the letter, which is B. So that's where we get 0B. Index, this is what chugs us along. So this is like the piston in the motor. I hope I'm explaining. I hope that's the right way of thinking of it. Index equals index plus 1. So it chunks it into 1. So now index equals 1. While index is less than the length of fruit, which it is, it's 1. And the length of fruit is 6. Letter equals fruit index, which is 1. So then the one that's in the first position in fruit is A. Print index, which is 1. Letter A. Moves it on to the next one. Oh my word, I can't believe I understand that.
Another thing we tend to do is to look through strings and look at strings and dig data out of strings. Python is excellent for doing sort of these kinds of lookups. And so we can write a simple loop. We can write a for loop that creates some kind of a iteration variable like index. And given that we know that these positions are 0 through 5, we can set this to be 0. And then write a while loop while the iteration variable is less than the length of fruit. And remember, this is 6, so it's going to be 0 through 5. 0 through 5 are the values we want to generate. And then we can look up one at a time, pull out fruit sub index, so fruit sub 0, fruit sub 1, 2, 3, 4, 5, and then print out the position and the letter index, and then add 1 to index, and it runs. This will run 6 times, 0 through 5, and out we go to produce this output right here. And so that's one way of looping through strings. That is a basic indeterminate loop, but we construct carefully an iteration value, and work our way through that loop data. The other way is to use a determinate loop, a for loop. And generally when we are able to use a while loop,
Looping through strings, a definite loop using a for statement is much more elegant than the crud back here. Yeah, I like that.
data. The other way is
The iteration variable is completely taken care of by the for loop. The iteration variable is taken care of. Fruit equals banana. For letter in fruit. Print letter. Oh, so we don't even need to mess with indexing at all or anything? Oh, so banana is the sequence it works through. Banana is the sequence. So it just handles it like for, I mean, letter could be any sort of variable. For in fruit, which is banana, print letter, which is this. B-A-N-A-N-A.
is to use a determinate loop, a for loop. And generally when we are able to use a while loop or a for loop, all else being equal, we generally prefer a for loop. And so here we have the for keyword and fruit, and it's an in. And so for letter in fruit, well, that just says letter is our iteration variable, and it's going to take on the successive values of each of the characters. So this loop is going to run 6 times, and letter is going to be B-A-N-A-N-A, banana. I'm always terrified when I make these slides that I'm going to misspell banana, because somehow I always think that there are 2 N's somewhere. I don't know. It's not one of my favorite words to spell. I actually didn't choose banana as the constant. The author who I borrowed the textbook from, Alan Downey and Jeff Elkner, they used banana, and so I'm still using banana. So some of the jokes in the book aren't my jokes. They are the jokes of Jeff and Alan. So here are just 2 equivalent, you know, so you can have the while loop. They sort of both do the same thing. They both just...
Oh. Index equals 0, while index is letter equals fruit index. Print letter. This is the same as what we saw before. Does the same thing, but it just is a little more chunky. This stuff right here, the length fruit thing, while length or while index is smaller than the length of fruit, 6. Wait, what? Oh, because for the yeah, okay, it is 6. Letter equals banana 0. Okay.
Just print the letters out one time through. Each of these loops runs 5 times. But you can see how the determinant loop, the for loop, is a prettier loop, unless you truly somehow need to know this number as you're going through the loop. But if all you're doing is going through and you want to touch in order each of the characters of the string, you then simply write a for loop because it's more elegant. The less code you write, the less chance there is for you to make a mistake. And so the fact that these are equivalent, this is 2 lines of a loop, and this is 4 lines of a loop. That's twice as many places as you could make a mistake, because you might, misspell index or something. I mean, why even make an iteration variable if you don't need to make an iteration variable? And so we can do things that...
Okay. We're getting there. This is a simple loop that loops through each letter in a string, counts the number of times the loop encounters the A character. Interesting. Word equals banana, count equals 0. For letter in word, which is banana, if letter O is A, count equals count plus 1. I get that. That's easy enough.
Harken back to our iterations and loops chapter, where anything that you can do in those things, like look for the largest letter, look for the smallest letter, search to see if a letter exists, or say count the number of A's in the word banana. And so that's what this is doing. And so we have a counter. So again, we do something at the top of the loop, we're going to do something in the middle loop, and then we're going to print it out at the bottom. So we start our counter at 0, we're going to loop through all the letters, and then if the letter is A, then count equals count plus 1. This is kind of a pattern in a loop where we're noticing something, and instead of like we did it earlier where we said found equals true, well, we're going to count them this time. So if we have 1, we'll get 1. If we have 0, we get 0. And
found equals true.
In a loop where we're noticing something, and instead of like we did it earlier where we said found equals true, well, we're going to count them this time. So if we have 1, we'll get 1. If we have 0, we get 0. And how many ever there are, but there should be 3 because it's going to run 3 times, and there's 3 A's in banana. And so this is a conditional within count. We've seen counts, we've seen conditionals in loop in prior chapters. And so again, I love the
deeper into in. The iteration variable iterates through the sequence ordered set. The block body of code is executed once for each value in the sequence. The body of code is executed once. Oh. Yep, I get it. Sorry. The iteration variable moves through all of the values in the sequence. Yep, I get that. Iteration variable. Okay, I get it. So that's essentially a program. And it's like so small.
In keyword in Python. It again reminds me of set notation in algebra. If you're a math whiz, if you're not, don't worry about it. Or maybe you will be a math whiz and you'll say, "Whoa, this set notation reminds me a lot of the in keyword in Python."
Nope, not me.
So again, It's for iteration variable letter. Again, don't get stuck with letter. I just happen to be using it here. In banana. And that is for each character in the string banana. Run this loop once, changing the variable letter to be the particular character that we're pointing at. And so it's taking care. For is taking care. I happen to be using it here. In banana. And that is for each character in the string banana. Run this loop once, changing the variable letter to be the particular character that we're pointing at. The variable character in the string banana, run this loop once, changing the variable letter to be the particular character that we're pointing at. And so it's taking care. For is taking care of a lot for us, right? And so
for letter in banana, print letter, the iteration variable iterates through the string. The block body of code is executed one. Okay, that's so done. Okay, no. Advanced letter, print letter, no. Advanced letter, print letter. So that's like there's the loop. Yes, and it moves on.
So this is sort of this really smart for loop. The for loop is, both deciding how many times to run the loop, in this case 6, and it's advancing the letter. So advance, print, decide whether you're done, 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 advance, print, decide whether you're done. I am now done because we're done with that particular string. And so you can think of the for as, magically doing all of this for you, of both deciding how long to run the loop, when you're done or not, and moving down through all the successive letters in the loop. So up next we'll do that particular string. And so decide whether you're done, advance, print. We're done with that particular string. And so you can think of the for as, magically doing all of this for you, of both deciding how long to run the loop, when you're done or not, and moving down through all the successive letters in the loop. So up next we'll do
moving through all the successive letters into the loop. Okay.
talk a little bit about additional things that we can do with strings.
Oh, let's move it back. It is late. Okay, so real quick here. For n in banana, print n. Banana. Right? Because it's usually going to be like so n is going to be like B. Oh man, I'm scared, bro. I don't know if it's going to be banana or this one. No, it's going to be banana. Oh, 27%. Yes. Oh, yes. Oh, that feels great. That feels good. That feels really good. Okay. So we're done for the most part tonight, but I do want to try something here. We're going to try and just start on this project. Just briefly. Just briefly. I'm not going to spend too much on this. If it's odd, print weird. Number equals Please enter a number. Shouldn't be while. If number equals is this like not weird? The comma? Don't you understand commas? I thought commas were like cool to use. Does it need to be in like brackets? We'll just do one. How about that? One. So why didn't that work? Okay. Oh, that's not wrong. Or that's not right. Wait for it. Heck yeah, dude. So theoretically, I just need to figure out how to throw in all the weird print weirdest numbers weird. Wait. Perform the following conditional actions. If n is odd, print weird. If n is even, and in the inclusive range of 2 to 5, which is 4. Because other than just spelling it out. So it's 100. I don't know how to do this. I don't know how to do like every other. If n is like. Because it's like I can do this, right? 24, not weird. But what I don't get. And I can also do like if number let's just mess around right here. We'll save this. What is this? Hacker rank 1. If number is greater than or equal to 1. Print weird. I'm making this way harder on myself, but I don't know how to do it otherwise. I would literally just type out every number, and that's so not efficient. But we could do this though. Elif number is greater than or equal to, whoops, greater than or equal to 100. Print oh gosh, I have no, there's no. The following is another simple way to solve this problem. Okay, strip. N equals input. If n percentage of 2 equals. Elif. Ooh, this is a little over my head. Here we go. Okay, so I don't know what strip is. What is this, discussions? This is great. N equals in. Okay, so this turns whatever this is into an int. Input. Strip. I don't know what strip is. If n. What is this? A percentage 2 is not... Wait, no, is? Does not equal 0. You can have or? You can have an or? Or n is greater than 5. So this is the first, like, range. If n is greater than 5 and n is less than 21. Print weird. If, or elif, excuse me. You didn't have an else. Do you need an else? And percentage of 2 is equal to 0. And n does not equal range 621. I don't know about this either. Print not weird. If n is less than or equal to 5. Oh, there's an else. Okay. I want to look into this next time we stream, but we're not going to do that right now. We're not going to do that right now. Wait a second. Week 1 and 2. Have I been reading this wrong? So this is like week 1 and 2. So it just has us do this same thing twice. Not a bad thing. It already has us jumping into the Corey's intermediate. Ooh, that'll be fun. I'm so excited. I like this a lot. I'm really enjoying coding. But I think that's going to do it for now. I think that's going to do it for now. I'm slowly understanding, man. Just because I don't understand this whole percent thing now doesn't mean I won't. Does not mean that I won't. But thank you guys so much for watching. Here, we'll do this. There we go. Thank you guys so much for watching. Hope you guys have a great weekend ahead of you. I will probably be streaming some tomorrow. I like this enough to want to, do it even on the weekends and stuff. So, feel free to leave a comment below if you guys have a prayer request. Love to be able to pray for you guys. Love God, love people. And I will see you guys in the next stream.